Hello again and welcome to part 2. In this section we're going to cover polar alignment and we're going to show you what polar alignment actually is, how to do it, and also we're not going to make it exclusive to mounts such as the MEQ6. I'm going to cover sort of basic mounts as well, and the different ways to cover it, and not only whether you've got a polar scope or whether you haven't. And we're going to just go through pointing out some of the controls to you and what they do to avoid any confusion. And we'll also introduce you to a very simple free piece of software. So let's get on with it.
Right, so what is polar alignment and how does it work? Well, for a moment let's imagine that the Earth is a ball, and this ball has a stick that passes directly through the centre of it. One end is the North Pole, one end is the South Pole. Now if we are in the Northern Hemisphere, it doesn't matter where we are in any of these positions or what the rotation of the ball is. The North Pole will always be in exactly the same place. It's a constant because it's part of the axis of the actual rotation. So let's have a look at that in a little bit more detail. Okay, for this next section we're going to introduce you to a piece of software called Stellarium. It's a free piece of software, and in my opinion, if you're even remotely interested in astronomy, it's essential. It's an essential piece of kit. It's basically a home planetarium. So you tell it whereabouts in the world you are and what time it is, and it will show you exactly where everything is in the night sky. Now for this demonstration we're going to use it, and what I want you to do is imagine we're now standing on that ball that we showed you in the previous demonstration. Now if we face north and start to look up, we'll find Polaris, which is the tip of that stick in our last diagram. You know, the sort of the axis. Now once you've done it a few times, you'll get in the habit of just being able to spot Polaris straight away. For the beginner, the easiest way to do it is if you locate this particular asterism. An asterism is a name that we give to an identifiable group of stars that are within a constellation, and this one we refer to as the Big Dipper. It looks like a pan. Now if we locate this pan and then locate these two stars, which are fairly bright stars, we call these the pointer stars because they will always point roughly to Polaris. If you find those two, move along, the next star you find is Polaris, because Polaris is quite a dim star. Now once you've located Polaris, we can start to do our polar alignment, and at this point I'd like to point out that we actually lied a little bit in the previous demonstration, because the stick doesn't go exactly through the centre of the ball, it's actually off centre a little bit. So Polaris doesn't stay in exactly the same position, it actually forms a small circle, and it does this once every 24 hours, matching up with the rotation of the Earth. Now this is why when we look in our polar scope we have Polaris as part of a circle. This is obviously forming the circle that's the rotations of Polaris. If the stick went directly through the centre of the ball, then Polaris would always be in the middle of the cross. Now it's also important to note that when we do polar align, we align our mount, we don't align our telescope, it's the mount that you're aligning, and you're aligning your mount to the axis of the Earth's rotation. Now when you've done that, it means that you should be able to just turn the right ascension control on your mount, and your telescope will form an arc as it moves. It'll move your telescope through an arc, and that arc will follow the rotation of the stars. Now, so if you point at any particular star and you start to either turn your right ascension if you're on a manual mount, or if you're on tracking mount, it's motorised, and basically your motors rotate your telescope at the same speed that the Earth's rotating. And we'll just speed that up to demonstrate. And you can see if we had polar aligned our mount and we're now turning our right ascension at the right speed, we would actually be following this star, it'll track it, which is why it's important that we polar align. It means then that we can track particular objects. If we didn't, they'd be starting moving out of view. And if you're imaging, then obviously you want your alignments to be as accurate as possible, because you want as little movement as possible. You want to try and keep your particular object right in the centre of view of your telescope. So next we're going to move on to actual alignment. Right, I hope we haven't fried your brain too much with all this talk about balls and sticks and rotations and axes and everything. It's just that I happen to think that if you understand why it is that we do something, it helps you to understand how to do it. So now we're just going to introduce this piece of software called Paula Finder. It's a very tiny utility, it's free, and you can download it from the downloads section on Astronomy Shed website. Now once you've installed it, what you need to do is just set it up, and it's just a very simple setup process. The first thing that we need to do is to click this icon, and we have a little settings box opens up. Now the first one is for number of charts. I usually have it set at 4, which basically means that we've got 4 charts on the go at the same time. The next option, show view through telescope. As you probably know, looking through a telescope, it inverts things, turns them upside down, and it's the same with the view through your polar scope. So you want the diagrams to match up with the view through your polar scope, and so that's why you need that one ticked. Now the time increment per chart I have set at 10 minutes. If you look at my charts here, you can see that they're actually 10 minutes apart, and you can set that time to whatever you want. But basically what it does is it allows you to print off a chart in your home and go to wherever you've got your scope set up and everything, and you've got a few different options there, for giving you a chance to sort of mess about and get things right. The next section, use system time. Well, 9 times out of 10 your computer time's fairly accurate, so it's a good idea to just have that ticked. And once we've got all that in, just click OK and move over to the next little icon, which is this one. And in here, all you have to set is your longitude for where you live. What it will do then is it gives you a very accurate representation of where Polaris is for any given time. And if we look at the reticule in a polar scope, you can see that this circle represents this circle here. Obviously ignore where Polaris is in this, because as we've shown earlier, this reticule rotates with your RA anyway. And we're going to use Polar Finder for a couple of things a little bit later on. Primarily, it's very, very handy if you've got one of the mounts such as an EQ5, where, to be honest, the clocks on an EQ5 are the next best thing to useless in my opinion. And I'll show you another way of polar aligning without using the clocks on an EQ5, and I'm sure that you've seen all over the place people that struggle with them particular clocks, so we'll do it a different way. And that's it for this piece of software, but again it's a must-have really.
Okay, firstly an introduction to the controls that you're going to use in your polar alignment. Firstly, the altitude bolts, that would be this one and this one, and these work in conjunction with each other. As you unscrew one, you must then tighten the other, and what this does is it moves your mount in this direction over this axis, so it's in effect up and down, hence why altitude bolts, because it adjusts your altitude. Next we have your azimuth bolts. These are your azimuth bolts each side, and what these do is they rotate your mount on its axes on the tripod like so, so that if we slacken this one off, you'll see as I start to tighten, the mount rotates. Now because there are 2 of these bolts, what you need to do is use them in conjunction with each other. They should both be tight, and then if you're making an adjustment, you slacken one off and tighten the other one by the same amount. If you've left any slackness in any of these bolts, you are going to get a movement like this in your scope, which means, if you knock it, anything that you move, it's going to knock your alignment out. So it's important that they're actually, when set, that they're tight against each other. So just like the altitude bolts, as you slacken one, you tighten the other one, and that's azimuth bolts. Right, we've finally got to the stage where we're going to do a polar alignment, and first of all I'm going to do it with the synscan controller. After that I'll show you a quick way of doing it with such as an EQ5, where the clocks are different and not very good, and then we'll cover a brief alignment with a scope that doesn't have a polar alignment scope in the mount. You might notice on mine that I've got an extension on my synscan controller. That's because I just find that the lead on the standard controller is just far too short, and you can add just a 9-pin to 9-pin male to female extender. It just makes things a little bit easier. And also I'll point out at this stage that I would normally have my scope on and my weights on, and I will have balanced as well. I'm going to cover balancing probably in the next video, and I just find it that way, with everything being fitted on, if there's any movement going to take place, you know, it's already happened when I've been putting my scope on and everything. I don't want to really disturb my alignment by, you know, messing about with my mount and putting my scope on and putting my weights on and everything. Two sort of different trains of thought on that. Some people prefer to align without the scope on. Personally, I prefer to align with it on for the reasons that I've stated. So let's take a look. Right, when you come to put the details into your synscan controller, you're going to need to put in a few details. And you're going to need your latitude and your longitude, and you're going to need the date, and you're going to need the time. Now, for the time, I actually use this, and it's something that I just bought off eBay. It's a travel alarm clock. It does in sort of 12-hour and 24-hour times, but it actually connects to an atomic clock about 1 o'clock every morning and corrects itself. And for the sake of sort of like £7 UK, I thought, you know, it's ideal just to keep in my box, and I know that I've got, you know, my time and dates all there, and I can just read it straight off. I mean, okay, granted you could read it off your laptop, but you know, I mean, if your laptop's run on batteries and only used for Astro, then, you know, things can start drifting a little bit. Just something that I use. So let's go over to the controller. Right, here we are with our controller, and obviously the first thing we're going to want to do is to power the mount up, and once we switch that on, the controller will start to come to life and we'll get a beep like so. Everything's come to life. Now then, the first thing we're going to want to do is enter our location, which is your latitude and longitude. Mine are already in, so you know, you need to just put your own in basically. Set time zone, well, I'm in the UK, so again that'll be left at 0. The date, at the moment it just remembers the last day that the hand control was used on, which this one is 0406, it's now actually the 7th. Remember that it's in the American format, so the month comes first, it's month, date and then year. So we're in the 4th month, which is April. Let's move over, change that to the 7th, enter, and now we need to enter the time. And the time at this moment is 14:13 and 51 seconds. So we'll put in 14:14. 14, 14, 0, 0, enter. Just double check the time. It's now put it into sort of, you know, a PM time for you. 02:14 and 8 seconds PM, which is, you know, it's right to about the second that. We accept that, press enter. Daylight saving, well in the UK at the moment, yes we are, because the clocks went on not too long ago, so my answer is yes at the moment. Obviously when it's, you know, winter, it's no. So enter. And now we get the important information, which is this, and it says Polaris HA equals. Now if you can see that, the HA equals that it's giving us is the time since Polaris last transited. It's not the time that you know, it's not how many hours Polaris is going to transit, it's the time since Polaris last transited. Now we can leave that for as long as we want, because this will actually keep time. And what we'll do is I'm going to put this in the rest now, change camera angles, and we'll just take a look at it again. But like I say, you can take as long as you want with this part now, because it will actually keep time, that. So we'll just move into the adjustments now on the mount. Okay, remember earlier that we said that the right ascension clock on the mount is actually a clock covering 24 hours. And we also calibrated it to the transit point of Polaris in our reticule. You know, putting the little Polaris at the 6 o'clock position and then 0 in the ring. That's actually calibrated now, and it's calibrated to our synscan handset. So if we look again on our synscan handset, like so, we can see Polaris HA equals 00.12, so that's 12 minutes past midnight. If we then transfer that time by turning the mount in right ascension to 12 o'clock, and then 12 minutes past, each one of the small notches is 10 minutes, so we have 10, 20, 30 minutes. We have a bigger mark then for the half hour, so 10, and just give it that little bit to make up for the 12, and lock at that position. Now next we're going to have a look through the polar scope, and what happens is that the small Polaris in our polar scope is now at exactly the right point for calibrating to Polaris the star itself, and that's what we're going to show you next.
Right, if we're now looking to our polar scope, this is the view that we're going to get. Now what we're going to do next is just flick over to a graphical representation of doing the alignment. Okay, now we want to imagine that we're looking through our polar scope and we can see Polaris just here. And what we need to do next is using only the altitude and azimuth bolts on the mount. We need to make Polaris come down and across and centre it in that little circle, like so. Once you've got Polaris centred in that circle, that's your mount polar aligned. Right, at this point I know exactly what you're thinking. You're thinking, surely there's a way to practice all this inside when it's cloudy, so that when it's not cloudy I can actually be outside and spend as much time at my scope as I can. And the answer to that is yes, there is a way to do it, and that's what I'm just going to show you now. If you remember earlier, I introduced you to a piece of software called Polar Finder, and what we're going to do next is just flick over and look how you can compare what you see in your polar scope to what you find in Polar Finder. Right, whilst I was doing everything earlier, I also had Polar Finder running on my home PC. Now if we look at this diagram, I've actually just drawn a white line through the centre of the cross in the polar scope, just to make things a little bit easier to see with regards to positioning. Now if we look at the times that I was setting up for the demonstration, I also took a screen grab of Polar Finder, and if we look at this diagram and we look at the time that I was actually doing the setup, you'll see that they actually compare. So what you can do is, if it's cloudy or you just bored one night and you just want to practice and learn sort of the technique, what you can do is have Polar Finder running on your laptop or your PC, practice what it is that you've learned so far in this video, and then look through your polar scope and compare it to the diagram in Polar Finder, because you should see that if you've done everything right on your scope and your mount, when you look at Polar Finder you should see exactly the same thing, which is what we're seeing here. So it just shows that you're managing it and doing it successfully. Like I say, it's just a really useful way to do it, that and practice and practice and practice and get it right.
Okay, now that we've got our mount set up and it's polar aligned, next we need to move back to the home position. Now if when you first turned on your synscan controller it asked you if you're starting from the home position or if you're starting from the park position, tell it yes, because we actually are going to start from the home position, and that's where we're going to move it back to now. So what we need to do is release the right ascension clutch and rotate in right ascension to the line that we marked earlier, like so, and lock that clutch up. And also what we need to do, if I just move camera angle a little bit, is we need to do exactly the same thing for the declination axis. Release it and down to 0, which is now the mount in the home position, which is weight straight down, scope up. It's worth bearing in mind at this point, you might notice that you do have to turn your declination to sort of 90 degrees usually to be able to see through your polar scope. There's a bar runs through the middle with a hole in it, and that hole usually lines up when this is at 90 degrees, which is like so, with your scope going across ways. So back to 0,
And that's the mount back in the home position. Right, once you've got your scope back in the home position, you need to get your synscan controller and press the enter button. You'll now be presented with this menu: begin alignment, yes or no. Now that we're going to cover in another video, because next what we're going to do here is we're going to go on to simple polar alignments for scopes that don't have synscan, and also such as the EQ5 where the clocks aren't particularly good on them, and for scopes that are like lower down the scale that don't even have a polar scope. So that's coming up next. Okay, so what do you do if you've got an EQ5? Now the EQ5s are notorious for the clocks. They're not the most user-friendly thing in the world, and to be honest, the EQ5s are brilliant mounts, but the clocks just let it down. The weakest point of the old mount really. Now there are ways that you can set the clocks up on an EQ5, and there are tutorials about it on the net. But I just found it hard to grasp, and I just couldn't get my head around it. So this is what I used to do with mine. First of all, I used to set my mount up outside, and I used to print off a chart from Polar Finder, just like the one here. Next, what I used to do is take my printed chart outside and compare through my Polar scope the image that I saw to the Polar Finder chart, and I just basically used to match them up. So again, I would use my Alt and Azimuth bolts and make my picture in my Polar scope match up with the chart on the Polar Finder like this, and I found it was perfectly adequate. I used to image with it, and I didn't used to get hardly any drift. I had a motorised EQ5 and it used to be fine. Now the thing is that you also don't have to rotate the right ascension and match up your small Polaris and then drag it in. What you have to imagine is that if this reticule is centred, the perimeter of this circle is always in the same place. Doesn't matter how much you rotate it, the perimeter will still be here. So if it helps you, you can rotate RA and just make your little Polaris in your reticule and put that in a position, and then sort of line it up. But I didn't. I basically just used to look through and match it up just like I'm showing you now, and that used to work fine for me. So it's just a little tip for the EQ5. Next, what we're going to do is cover if you don't have a polar scope on your mount, sort of the lower end EQ mounts and everything. Now the chances are, if you've got one of the lower end mounts like that, you're not going to be imaging. It's not hypercritical to get as close an alignment as you can. So all you have to do in that case is look through the telescope itself. Find Polaris in the telescope itself, have your mount in the home position, everything's at home like we've covered previously, and then again using your altitude and your azimuth bolts, get Polaris right in the centre of your field of view in your actual telescope, like so. Now they do sell crosshair reticules in eyepieces that you can put into a telescope, and it can help you to centre that way. Or you can start off with a wide field eyepiece and centre Polaris then in your scope, and then just go on to a narrower field, sort of a 10mm or a nice small sort of field of view eyepiece, and just recenter it again, just being a little bit more accurate. And for visual, you'll still track perfectly fine just using your right ascension control on your mount. And I think that's basically it. I think we've covered everything there. And this one's been a really hard one, to be honest, and I'm glad that I've got it over with, because there's been that many cuts and outtakes and everything else. So once again, thanks for watching.